I welcome you once again to my page. This is Oasis Online Math. In today's class, we are to solve the numeric value of unknown value x here. And if we take a look at this equation, it's of polynomial. Of course, it's of multiple powers and multiple powers of the variable. So we are asked to find the value of x if x squared plus 3x plus 2 all in bracket raised to the power 4 plus x squared plus x minus 2 all raised to the power 4 is equal to 16 into bracket of x plus 2 all raised to the power 4. It's if you take a look at this expression x squared plus 3x plus 2 is a quadratic expression. Is this factorizable? Yes, it is factorizable. So we should look for the two factors such that if we sum them together, it's going to be plus 3, and if we multiply them together, it's going to give us plus 2. The two factors there are 1 and 2, because 1 plus 2 is 3. 1 plus 2 is equal to 3, and same 1 times 2 is going to give us 2. So the sum satisfied and the product also satisfied. So our factors are plus 1 and plus 2. So if that is what we're going to use, so we should have x plus 1 into another x plus 2, and we should not forget it has a power 4, because everything here is still raised to the power of 4. Okay, and again we should ask ourselves again, can we factorize this? Of course. Our sum is minus 1, our sum is plus 1, and our product is minus 2. So we should have x minus 1 and x plus 2. The product is minus 2 and the sum is minus 1, plus 1 rather. Okay, so we write the right hand side as well. Okay, and we should not forget that this power belongs to this whole expression, belongs to the two binomial expressions there. So it means that power will be distributed on each expression. That is x plus 1 all raised to the power of 4 multiplied by x plus 2 all raised to the power of 4. Okay, then plus, let's do the same thing. We have x minus 1 all raised to the power of 4 multiplied by x plus 2 all raised to the power of 4, then is equal to x into x plus 2 all raised to the power of 4. Then we should be careful that these are terms that they are common. On our left hand side we have a term which is x plus 2 is here, and also x plus 2. And if you also look at our right hand side, we can see another term that they're of the same. So let's factorize x plus 2 all raised to the power of 4 out, x plus 2 all raised to the power of 4. Then we are left with this and this. So that is what we are left with. So bracket x plus 1 all raised to the power of 4 plus x minus 1 all raised to the power of 4. Then let's close the bracket. We have is equal to 16x plus 2 all raised to the power of 4. From both hand side, that is the left hand side, you could see that x plus 2 raised to the power of 4, we have it in both sides, so we cancel out, we can strike them out like that. So we have on our left hand side we have x plus 1 all raised to the power of 4 plus x minus 1 all raised to the power of 4, then is equal to 16. So right now our equation is now simpler, so we can decide to expand the left hand side. So when we expand x plus 1 all raised to the power of 4 using our basic idea of binomial expansion, we could have don't forget our you can use your Pascal triangle, where we have 1 1 1, then 1 2 1, we have 1 3 3 1, then we have 1 4 6 4 1. So power 4, this is where we are going to take our power 4. So we have our expansion, we have this form. Let's move to the left hand side better, so that we have x raised to the power of 4 plus x raised to the power of, with the coefficient 4, coefficient 4, then x raised to the power of 3, then 1 raised to the power of 1 is still 1, then plus the coefficient 6, that is this, x raised to the power of 2 now, plus then 4x plus another 1. So that is the expansion for all this. Then moving on, we have expand this. It's going to take the same shape. However, don't forget that this is minus, while this expression is taking plus here. So when it comes to minus like this, and you want to expand, the symbol, that is the plus and minus, will be alternating. What do I mean? It's going to take the same shape like this, what we first have here, but the signs is going to be alternating. That is x raised to the power 4, the minus will come like first, followed by this 4x raised to the power 3 plus 6x squared. Don't forget to be alternating. Then minus 4x, then plus 1. Don't forget everything is still equal to 16. From the look of things, you see that some terms can actually take care of each other. This 4x raised to the power 3 can take care of minus 4x raised to the power 3, so they can easily cancel out. So we can strike them out, strike this out. What else? We have a plus 4x, can also cancel out minus 4x. So we are left with this value. So we have 2 of that is 2x raised to the power 4, then plus we have this left, 6x squared plus another 6x squared, we have 12x squared, then we have 1 plus 1, that is 2, minus 16. Let's bring 16 in, everything is equal to 0. So this is a polynomial. So from what we are seeing here, let's simplify this. We have raised to the power 4 plus 12x squared minus 14 is equal to 0. So we look for the way of factorizing this, but take a look at this function, or this equation, this polynomial equation. We can see that we can easily reduce this equation by dividing through by 2. That is, if we divide through by 2, that is, we divide this by 2, we're going to have 1, divide this by 2, have 6, divide this by 2. So we can easily divide through by 2. Then we have not committed any crime. So we have x raised to the power 4 plus 6x squared minus 7, then is equal to 0. So this is where we are, and on that, then we can easily proceed by making sure that we factorize this equation. Then first and foremost, for you to factorize this equation, let's use a trial and error method. That is, let's say the value of x equals to 1. If x is equal to 1, let's check if x can actually satisfy the x equal to 1 can actually satisfy this. So we have 1 raised to the power 4 plus 6 raised into 1 raised to the power 2 minus 7. Definitely this will be 1 plus 6, 7 minus 7, 0. So x raised to x minus 1, x is equal to 1 is a root of this quadratic equation. If x is equal to 1 is a root, then x minus 1 must be a factor by bringing this x1 into that. So it's a factor. We want to factorize this polynomial equation. If x minus 1 is a factor, let's check another value if possible. Then definitely x minus 1, x is equal to minus 1 should be able to work as well. Let's substitute x minus 1 is equal to minus 1 here. Let's see whether it will work. Definitely. So we're going to have minus 1 raised to the power of 4 plus 6 into minus 1, then minus 7. Minus 1 raised to the power of 4 will definitely give us 1, because the power there is an even number. So we have 1 plus, then don't forget this is power 2, okay, 1 plus, then 6 into negative 1 raised to power 2. Negative 1 raised to power 2 will still give us positive 1. Positive 1 times 6, that gives us 6 minus 7 is equal to, definitely is going to give us 0. Therefore, x is equal to minus 1 is also one of the roots of that. If x is equal to minus 1, if minus 1 is a root, then x plus 1 is also a factor, another factor. So how many factors are we supposed to derive from here? We're supposed to derive 4 factors. How do we get to know? Because we have x raised to power 4 plus 6x squared minus 7 is equal to 0. The reason why I said it's going to give us 4 factors is because of the highest power of the unknown. The highest power of the unknown is 4. Therefore, we shall obtain 4 factors. But we have obtained 2 from here. Then how do we obtain the remaining 2? Let's engage ourselves in using our long division method. Remember our long division method in polynomial, where we should put our p of x here. Then let's write this polynomial in order. That is, in decreasing power of x, we don't have power 3 here, so we can assume to be x raised to power 3 plus 6x squared. We don't have power 1, so we can have 0x, then minus 7. Then let's put in one of the divisors, one of our divisors, and one of our divisors that we have here is the factors. Okay, we have the factors to be x minus 1. Let's use x minus 1. Let's use x minus 1 first. So we are going to use x minus 1 to divide this polynomial. So x goes in x raised to power 4. We shall have x raised to power 3. Then we use x raised to power 3 to multiply this. Then what do we have? We shall have x raised to power 3, x raised to power 4, x raised to power 4. Then again multiply by minus 1. We shall have x raised to power 3. So let's subtract that from it. If we subtract x raised to power 4 from x raised to power 4, definitely it will strike out. That will give us 0. Then subtract minus x from 0 is going to give us positive s cubed. Bring the remaining values down. Okay, we shall have plus 0x square. To multiply again, we go again, repeat the same operation. So we have x raised to power 3 minus x raised to power 2. So we subtract again. So we have x squared from x cubed from x cubed. That will strike out. So we shall have, then we want to subtract minus x squared from 6x. So we're going to have 7x squared. Bring the remaining value down. We have 0x minus 7. So we have that. We go again. X can still go in 7x squared. So we shall have plus 7x. So 7x times x, we shall have 7x squared, then minus 7x. So we subtract again. Once we subtract that, then this 7x squared, definitely we are going to become 0 there, because if we subtract 7x from 7x, we shall have 0. Then subtract minus 7x from 0, we shall have ordinary 7x. Then bring the remaining 7 down, we have 7. Now let's go again. X going in x, 7x, we shall have ordinary plus 7. So plus 7 to multiply this, we shall have 7x minus 7. And if we subtract that, we shall have 0. We're going to have 0. So therefore it means this polynomial, okay, is, let me copy it down so that we'll have it there. Let me copy it down. This polynomial will now become this factors that we use x plus 1, that is this value, x plus 1 We have x minus 1 rather into this factor that we have here, the quotient that we have s cubed plus x squared plus 7x plus 7 plus 7x then plus 7. Then don't forget it's still equal to 0. We are not done because we've just gotten two factors. That is, we just factorize this in two expressions. We still need to factorize this, but don't forget that earlier we said x plus 1 is also a factor, because we just use, yes, x plus 1 is also a factor. So let's use x plus 1 to divide this polynomial. Let's use x plus 1 to divide that polynomial, and let's see what we have. So we should go again using our long division method, where we have our normal table that we drew earlier. So we're going to put our x plus 1 here. Then we have x cubed plus x squared plus 7x then plus 7. We go again, we have x goes in s cubed, we have x squared, then s squared times x plus 1, we have s cubed plus x squared. So we subtract again. If we subtract that, we see that this will take care of this. Likewise, this will also take care of this. We are left with ordinary 7x plus 7. So we go again, we say x goes in 7x, we shall have plus x plus 1, we shall have let me paste it here. This polynomial will now give us x minus 1 as one of the factor, then x plus 1 plus, what do we have left here? S squared plus 7. S squared plus 7. Everything equal to 0. Don't forget, we are looking for that factor that is the root of that polynomial, or the zeros of that polynomial. So definitely, if all these are multiplied to be equal to 0, definitely x minus 1 will be equal to 0. Then it means x will be equal to 1. Likewise, x plus 1 equal to 0. Definitely our x will be equal to negative 1. Also x squared plus 7, that's not factorizable, so it means our x squared will be equal to negative 7, and therefore our x will be square root of negative 7, and the square root of negative 7 will be root of 7i. That is, we can write this as x will now be positive or negative root 7i. Therefore, the values of the values of s are either 1, that is the zeros of that polynomial, minus 1, or plus root 7i, or minus root 7i. These are the values to that x that we are asked to look for. If you enjoyed this, please do make sure you watch out for more interesting video on my YouTube channel. Thank you very much. God bless you.